So, have you ever stopped to think about how we can find any single spot on this huge spinning rock we call Earth? I mean, it seems like it'd be impossible, right? But the answer is actually super simple. It all comes down to an invisible grid. And in this explainer, we're going to build that grid from scratch and see exactly how a few imaginary lines organize, well, pretty much everything.
All right, so here's the game plan. We're going to start with the absolute basics, a model of our world. Then we'll draw the most important line of all, the Great Divider. After that, we'll add the horizontal lines, then the vertical ones. And once our grid is built, we'll see how it creates Earth's climate zones. And finally, we'll tie it all together and talk about why this whole grid thing even matters.
Okay, first things first. If you want to draw a map of the entire world, you kind of need a model of it to start with, right? And the absolute best, most accurate one we've got is the globe. And that phrase, true model, is super important. Why? Well, because our planet is a sphere, not a flat piece of paper. So a globe, which is also a sphere, is pretty much the only way to show everything in its proper shape and size without stretching or squishing things, you know? So, you know how every globe has that little rod going through it and it spins on it? That's meant to be the Earth's axis. It's this imaginary line that our planet rotates on. But the most important part? It's tilted. And trust me, that's not just to make the model look cool. That tilt is everything. It's the entire reason we have seasons. Okay, so we've got our spinning, tilted globe. But right now, it's just a blank sphere. To actually map anything on it, we need a starting point, a main reference line. And that brings us to the biggest, most important line of all, the equator. You can think of the equator as the Earth's belt. It's this imaginary line that runs right around the planet's widest point, splitting it perfectly into two equal halves. It's our ultimate starting point for measuring anything north or south. And because it's our starting line, we give it a number, 0. 0 degrees. That's the baseline. Everything, and I mean everything, measured north or south, starts from this exact line. So what about those two equal parts the equator creates? Well, we call them hemispheres. Makes sense, right? Hemi means half. So everything north of the equator is the northern hemisphere, and everything south is, you guessed it, the southern hemisphere. Easy.
All right, we've got our main starting line at 0 degrees. Now it's time to add the rest of the horizontal lines. You can picture them like the rungs on a giant ladder that wraps around the globe. And these lines have a name. They're called parallels of latitude. Now, technically, there's a line for every single degree, but these are the big ones you really need to know. You've got the Tropic of Cancer and the Tropic of Capricorn. They basically fence off the tropical part of the world. Then you've got the Arctic and Antarctic circles, which are like the gateways to the super cold polar regions. And the whole system tops out at 90 degrees north, the North Pole, and bottoms out at 90 degrees south, the South Pole. But hang on, just knowing how far north or south you are isn't enough, right? It's only half the address. To really pinpoint a location, like for your phone's GPS to work, we need to finish the grid. And we do that by adding vertical lines that go from pole to pole. These are called the meridians of longitude. So here's a key difference. Those latitude lines were full circles that got smaller and smaller. But these longitude lines, they're all half circles. The best way to picture it is like the lines on a peeled orange. They all start at the top, run down the side, and meet up again at the bottom. They all connect at the north and south poles. And this is a really, really important difference to remember. The parallels of latitude are all different lengths, right? The equator is huge, but the ones near the poles are tiny. But the meridians of longitude, they're all the exact same length. Why? Because every single one of them makes the same trip, from the North Pole all the way down to the South Pole. Okay, so just like we had a 0-degree line for latitude, the equator, we need one for longitude. And we call this one the Prime Meridian. But here's the thing. While the equator is the Earth's natural middle, there's no natural starting point for east-west. So people just had to pick one. And they decided it would be the line that runs through the Royal Observatory in Greenwich, England. And just like the equator, this line divides the world into two halves, the eastern and western hemisphere. All right, our grid is officially complete. We've got lines going side to side and lines going up and down. So now for the cool part. Let's see what this grid actually does. While longitude is awesome for location and time, it's the latitude lines, those horizontal ones, that have a huge impact on our planet's climate. Let's start smack dab in the middle, in the hottest region of the planet. This is known as the Torrid zone. So the Torrid zone is basically everything sandwiched between the Tropic of Cancer and the Tropic of Capricorn. Because of that tilt in the Earth's axis we talked about, this is the part of the planet that gets the most direct, intense sunlight all year long. We're talking the sun is literally right over your head at noon at least once a year. And that's why this area gets the absolute maximum amount of heat. Okay, now let's move a little further away from the equator, either north or south. Here, we get into the temperate zones. And, there's a pretty good chance this is where you live, since a huge chunk of the world's population does. The key thing about the temperate zones is that the sun is never directly overhead. Its rays always hit the ground at an angle. Think about a flashlight. If you point it straight down, you get a small, intense circle of light. But if you angle it, the light spreads out and is less intense. That's exactly what's happening here. And that's what gives us those more moderate, mild temperatures. And last but not least, if we go all the way to the top and the very bottom of the globe, we find the frigid zones. These zones, everything inside the Arctic and Antarctic circles, all the way to the poles, get the least direct sunlight by far. I mean, the sun's rays come in at such a crazy sharp angle that even at noon, the sun barely peaks over the horizon. That extreme slant just drains the energy out of the sunlight, which of course means it gets really, really cold. Okay, so let's recap. We started with a plain old sphere. And now we have this detailed globe covered in lines that even map out climate zones. But so what? What's the real point of all this? Well, it really all boils down to three huge things that basically run our world: location, climate, and time. Here's the final piece of the puzzle. Latitude tells you your north-south position. Longitude tells you your east-west position. Put them together and you have a precise, unique address for any spot on the planet. That's literally how the GPS on your phone works. And as we just saw, those latitude lines are the master controllers of our climate. And longitude, well, those vertical lines are the foundation for all 24 of our global time zones. So you see, this grid isn't just some dusty old concept from a geography book. It's like the invisible operating system for our entire planet.
And that just about wraps it up. But I want to leave you with one final thing to think about. Our whole system, the equator, the poles, all of it, is built around the way our planet spins. But what if you had a planet like Uranus? It got knocked over billions of years ago, so it literally spins on its side. How would you even start to draw an equator on a planet like that? Where would you put the poles? Kind of breaks your brain a little, right? Something to chew on. Thanks for joining me.